Hello students, in this video let us see about the carboxylic acid derivatives and its rate of hydrolysis, or you can say in other words what is its reactivity, right? So 4 particular molecules, compounds are specified to you. One is acid chlorides, anhydrides, amides and esters, right? So let us move on the topic main. If we represent the carboxylic acid derivatives in general as this, right, whereby L can be any one of this depending on what kind of molecule is under study, and if we are interacting it with a nucleophile, in this case since we are talking about hydrolysis, if the nucleophile is OH minus, then the reaction will proceed in the forward direction whereby nucleophilic acyl substitution will take place. This L group will be replaced by the nucleophile which is present within the reaction or which is attacking the reactant, right? As far as the mechanism is concerned, it is as shown here. So carbonyl group, there is a positive negative charge separations due to difference in the electronegativity between carbon and oxygen. In the first step, the nucleophile OH minus will attack on the carbon atom. Addition reaction will take place, resulting in a formation of this tetrahedral intermediate. This tetrahedral intermediate is however unstable and it will undergo elimination, resulting in the formation of the final product, where in the final product you can observe that your L group has been completely replaced by the OH group, the nucleophile which was attacking your reactant, right? Now, to find out the reactivity of a particular molecule, let us move on the main topic again. A hint has been given to you, just read it. Weaker the base, better is the leaving group and more is the reactivity. So whenever such question appears in your exam, what are you going to do is, you try to find out what is the tendency of that base, whether it is a weak base or whether it is a strong base, right? Let us move one by one. So in the first case, acid chlorides, chlorine. Can I say it is a strong base? What is a base? If I talk about the definition of Lewis base. Lewis base is the one which can donate electrons easily. But chlorine, being an electronegative element, is not going to donate its electrons easily. So it is a weak base. That means it is a good leaving group. Since it is a good leaving group, it has high reactivity, and so the replacement of this chlorine will be easier in this case, and it can be easily substituted by the hydroxyl group, right? So it can easily undergo hydrolysis. Move on the next, acid anhydrides. In case of acid anhydrides, if I consider this particular group, since it has a carbonyl group having minus I effect and it also has an oxygen which is an electronegative element, because of this it is an intermediate strong base. Okay, so being an intermediate strong base, it again is a better leaving group. So it's not a strong base, it's an intermediate strong base. Somewhere it is less basic. So it is also again a better leaving group, and so it's more reactive compared to the other two, right? So it can again undergo easy hydrolysis compared to that of esters and amides. Okay. In the third stage, consider the third molecule, that is esters. In case of esters, we are having this OCH3 group. OCH3 group has a positive inductive effect tendency. So it will show plus I effect. Due to this plus I effect, it is donating electrons, right? So due to this plus I effect, what is going to happen? Consider the carbonyl group here. It has negative charge and it has positive charge, the carbon atom. Now this OCH3 group, since it donates the electron, it will decrease the electron density on this carbon atom, and since the positive charge on the carbonyl group, carbonyl carbon, decreases, the nucleophile cannot easily attack this, right? That means reactivity of esters decreases, as well as I can say the basicity of this OCH3 group is more, right? Because of which the hydrolysis tendency of esters also decreases. Clear? Next, consider acid amides. In case of amides, there is a nitrogen which is directly linked to the carbonyl group. As we know, NHCH3, that is an amide group, is basic in nature. So it is a strong base, being a strong base, it is not going to easily allow the breaking of this bond, because of which it is not reactive and the hydrolysis will work very slowly for this case. So you can say in short terms, it is difficult to hydrolyze acid amides, right? To make it more clear to you, let us move ahead. So here a next hint is given to you that you need to check, or you have to check the positive charge on the carbonyl carbon, whether it is getting more intensified or not. If it intensifies the positive charge on this carbonyl carbon, then the nucleophile can easily attack on this carbon, right, being negatively charged. So we'll check that particular thing in this case. Consider again chlorides. Chlorine is electron withdrawing. So what you can say, the carbon's positive charge is going to get increased. So it will increase the positive charge on the carbonyl carbon. As a result, reactivity increases and hydrolysis increases. Okay, rate of hydrolysis increases. Check the next case. In esters, again OCH3 group, it's an electron donating group. Being an electron donating group, carbon will not increase its positive charge, rather it will decrease the positive charge on carbonyl carbon, right? So the reactivity decreases. Next, if I talk about anhydrides, it has an electron withdrawing carbonyl group, minus I effect, because of which you can say there is increase in the carbonyl carbon positive charge, however due to this complete group, but the overall effect is the reactivity decreases compared to that of acid chlorides. Next is about NHCH3. In case of NHCH3, that is amides. Amides case, it is NH3CH3, it's an electron donating group. So again carbonyl group positive charge will decrease, because of which reactivity decreases, right? There's one more concept to understand this. So now we have two extreme cases whereby we are aware till now that acid chlorides are highly reactive, so they can easily undergo hydrolysis. On the other hand, acid amides are least reactive and they cannot undergo easy hydrolysis. You can also confirm it with the help of the resonating structures as shown to you. So acid chlorides can be existing in this kind of resonating structures, and these are the resonating structures for amides. In both the cases, see the first case initially. In this case, as we can say, if there is a transfer of electron taking place, initially what will happen? Carbon will develop a positive charge, oxygen will develop a negative charge. The chlorine atom, which is having 6 electrons in as its valence electron, it will donate one of its electron pair, resulting in the formation of this particular resonance structure, right, forming a positive charge across it. But chlorine is an electronegative element. Being an electronegative element, it is not going to exist in this particular state for a larger period of time. So it's a highly unstable resonance form of acid chlorides. Rather, on the other side, we can also say there is no effective overlapping and no such resonating structure can exist in a good way, because carbon is having a 2p orbital and it has to overlap with chlorine's 3p orbital. Since there is a high amount of energy difference between both of these orbitals, so they are not going to easily overlap with each other, and so the probability for existence of this resonating structure will be nil, right? In the second case, if I consider, in case of amides, they can easily undergo such type of resonance. Reason, carbon 2p orbital, nitrogen again 2p orbital, having same energies, they can effectively overlap with each other and result in the formation of such resonating structures. Because of this, what can I say? Here, this bond can easily break up, resulting in easier hydrolysis, and this bond is not going to break easily because it can undergo resonance, and there is a double bond present between carbon nitrogen in this resonating form, whereby it gives more stability to the structure, and so bond breaking becomes more difficult, that is reactivity is decreased and hydrolysis will also be decreased. Clear? Now let us move towards the main question in concern. So see the question. What is your answer then? Amides are the least reactive and so they are difficult to hydrolyze. ठीक है? So that is about this concept. In the next video, I'll be giving you certain more tips within the organic chemistry field. Till then, work hard, take care.